Hello everyone. In this chapter, you will study the simplest form of ANOVA called single factors or one-way ANOVA. You will also study the F distributions used for ANOVA and the test of two variants. ANOVA, as it is presented here, relies heavily on calculators or computers. Now, please bring out your calculators and follow my calculation step by step here. Let's have a case about three sets of data. If I get a set of data is 1, 2, 5, and the second set of data will be 2, 4, 2, and the third set of data will be 2, 3, 4. Now, I would like to know whether those three sets of data have the same mean or they have a difference among those three sets of data. So, I would like to try it by using an ANOVA test. So, before conduct an ANOVA test, we need to have a hypothesis. For the null hypothesis, I will say mu1 equal to mu2 equal to mu3, and the alternative hypothesis will be at least one difference among the mean. And in this test, we would like to set the alpha will be 0.05. Okay, now we are going to do the ANOVA test here. Please follow my step. First of all, we need to calculate the means among those three sets of data. For set 1, we will calculate it. It will be 2.67, and x2 bar will be 2.67 also. And the third set of data, the mean will be 3.00. And also, we need to calculate and to check the degrees of freedom between each set of data. Now, we can know that the degrees of freedom between each set of data will be 3 minus 1. Since there are three categories and we simply minus 1 and we will get 2. And also we need to calculate the degrees of freedoms within the group. And we know that there are totally 9 number, and there are 3 groups here, and we get 6 finally. And the degrees of freedom in total, by calculation we can add those degrees of freedom between the groups and the degrees of freedom within the groups. It will be 2 plus 6 equal to 8, or you just simply name 9 number minus 1 will be 8. They're the same. So why we need to calculate the degrees of freedoms? As we are going to conduct an ANOVA test, and we need to use the F table, which is F distribution. So we need to find out the critical regions in F distributions. So for our reference, we like to choose an F distribution tables with alpha will be 0.05. And first of all, the degrees of freedom between is 2, and within will be 6. Besides that, we need to calculate the sums of square with total. And when we do this kind of calculation, we first need to find out all the numbers minus the x bar square the x bar bar is mean all the numbers, add them up and then divide the numbers of those set of data, and finally will be get 2.78, which means when I have those 9 numbers, I need to use those 9 numbers to subtract the x bar bar and get the square on it and get the summations. That is 1 minus 2.78 the square plus 2 minus 2.78 square plus 5 minus 2.78 square plus 2 minus 2.78 square plus 4 minus 2.78 square plus 2 minus 2.78 square plus 2 minus 2.78 square plus 3 minus 2.78 square plus 4 minus 2.78 square. And we finally get as a stop will be 13.57. Also, we need to calculate the sums of square within the group. And during this process, we only need to consider each number in that group minus the mean of that particular groups, and we get the summations on those data. Since we have 3 sets of data, so we need to get 3 summations which on different sets of data. So please remember and be careful, do not mess up on them. And first one will be 1 minus 2.67 square on it, and 2 minus 2.67 square plus 5 minus 2.67 square plus, for the second set of data, 2 minus 2.67 square plus 4 minus 2.67 square plus 2 minus 2.67 square plus, for the third set of data, it will be 2 minus 3 square plus 2 minus 3, and then square them, and final one square. And we got as stop will be 13.34, and we know that the summation, the sums of square between the groups will be same as st minus s stop. That will be 13.57 minus 13.34, and we finally get 0.23. Okay, after calculating the sums of square within the group, the sums of square between the groups, also the sum of square of totals data. Now we need to consider the mean square between the groups and the mean square within the group. Since the mean square between the groups will equal to SSB minus the degrees of freedom between the group, so we can guess it will be 0.23 minus over 2, it will be 0.12, and MS stop will be SS stop over degrees of freedom within the group. It will be 3.34 over 6, it will be 2.22. Now, for the final step, we need to test the F-test statistic, which equal to the MSB over m star, the mean square between the group over the mean square between within the group. That will be 0.12 over 2.22, and finally we get approximately 0.05. Since this data we get and we need to compare with the critical regions in the F distribution we mentioned before, now we're going to check the table. Now I will teach you how to check the table. First of all, you need to check the table relies on the alpha equal to 0.05 first. If not, you may need to find another tables. Okay, now first of all, we would like to check the degree of freedom in the for the numerator is 2, and then the denominator is 6, and we can check. Since we like to check 2, 6 in the F table, and we can, by this method, we can find out the number will be 5.14. That means it will be equal to 5.14. We'll compare with the F statistic, and we know that 0.05 is less than 5.14, which means it is failed to reject the H null. There is no significant difference between the three groups. So we can conclude that mu1 is equal to mu2 equal to mu3.